Alright, for problems 1 through 3, we're going to restrict the domain, find the inverse, and confirm it through composition, and then graph both the function and its inverse on the same coordinate plane. So first off, let me change the 0.2 to a fraction. So 2/5 is 2 over 10. When you reduce it, you get 1 over 5. So I'm going to restrict the domain. I'm going to say that I'm only looking at all x greater than or equal to 0. Okay, so now y equals 1/5 x squared. And I'm going to solve for x, so I'm going to multiply by 5 over 1. And so I get 5y. Okay, so I get 5y equals x squared. I'm going to take the square root of both sides, so that gives me plus or minus square root of 5y. And because I took the positive x's, I'm going to take the positive root. So then I get x equals the square root of, so you don't have to put plus, just write it square root of 5y. Switch the x and the y, and then change the notation. So this is what we got for our inverse. Okay, so now we have to confirm it, prove it with composition. So we're going to do f of f inverse of x. Oops. So let's see, f is 1/5 x squared, so I'm going to write 1/5. And in the parentheses, because this is 1/5, this is the function f of x, 1/5 x squared, right? So in place of in the parentheses, I'm going to put the square root of 5x. And remember, when you square a square root, you get rid of the radical. So this becomes 1/5 times 5x. So 5 times 1/5 is 1. So this gives you x. Okay, so now we have to do the other direction. So I take the square root of 5, and then instead of x, I'm going to write the f of x. Like that. And so 5 times 1/5 is 1. And so the square root of x squared is x. So this proves that our inverse is correct. I got x. Okay, I got x for both of them. So now we're going to graph. So when you graph, I just put some points, the reference points right here. And I added another one. I added 525 just because 25 is divisible by 5, so that gives me the 5. Because because of the 1/5, we're dividing all the y's by 5, and that's how you get these numbers right here, the y's. So I plotted the 4 points and connect them with a smooth curve. Remember, it's a parabola. It's half a parabola. So we switch the order of the x and the y to plot the inverse. So 0, 0, 1/5, 1, approximately right there. 4/5, 2, again approximately right there. 5, 5. Okay, so it goes something like this. And when we draw the line y equals x, that should be our line of symmetry for the two graphs. Okay, so this is y equals x. Okay, so we're going to restrict the domain. Sorry about that. X is greater than or equal to 0. And then we're going to find the inverse. So switch the f of x to y. We're solving for x now, so I'm dividing by 8. And so that gives me y over 8 equals x squared. I'm going to take the square root of both sides. So that leaves me plus or minus y over 8 equals x. Again, because I chose this domain, x greater than or equal to 0, I get the positive root. Okay, so x equals like this. And we switch the x and the y. And now I change the notation to F inverse. Okay, so now we're going to prove that we have the right inverse, that we got this answer right here right. So we're going to do F of F inverse of X and so we take 8 blank squared. Remember, in this blank we're going to write in our F inverse of X. So when you square a square root, you eliminate the radical, like that. And so 8 times 1/8, that becomes a 1, so this gives me X. Now we do the other direction. So that means that I'm going to start off with the square root, and then the 8 in the denominator, and then in the numerator, the x is your f of x function, so that's 8x squared. Okay, so what happens? The 8 over 8 cancels, and you're left with square root of x squared, which is x. Now, since both of them gave you an x, both compositions, then we know that our functions are inverses of each other. Okay, so now we're going to graph. Okay, so I'm going to use blue again for the original, for f of x. And I already did the points right here. Since a is 8, that means the y's get multiplied by 8. Now notice my third point. It goes way off my charts, my graph paper, so I'm not going to graph it. I'm just going to graph 0, 0, and 1, 8. And again, you know it's a parabola. It's just a very skinny parabola, or half a parabola. And then we're going to use pink for the inverse. And all I'm going to do is switch the points. So 0, 0 stays 0, 0. And 1, 8 becomes 8, 1. And then connect. And there's your inverse. Okay, we're going to restrict the domain to x greater than or equal to 0. Switch out the f of x, make it y. So now I'm going to solve for x. So I'm going to subtract 10. And so I get y minus 10 equals x squared. I'm going to take the square root of both sides. So that's plus or minus square root of y minus 10 equals x. Because I chose this domain right here for my x's, I'm going to choose the positive root right here. So x equals the square root of y minus 10. I'm going to switch out the x and the y. And then my final step is to write it in proper function notation. And we get this. Now make sure that bar goes all the way across. And so now we're going to confirm that our answer is right. Okay? We're going to use composition. So f of f inverse of x. So that means we start off with f of x. So parentheses squared plus 10. And inside the parentheses, I'm going to put the f inverse of x function, which is square root of x minus 10. So when you square a square root, you eliminate the radical. Oops, plus 10. And so 10 minus 10 is gone, and I'm left with x. Oops, that's an ugly x. But I'm left with x. Okay? So then I do f inverse of f of x. And so that's, start off with f inverse. And then it's going to be blank minus 10. So in the blank, I'm going to put in x squared plus 10. That's my f of x function, the whole thing. Now the 10 minus 10 is canceled to 0. And so that gives me square root of x squared. Well, square root of x squared is x. So I have shown that both compositions equal x, so that means that my functions are inverses of each other. So now we're going to graph. So the plus 10 is your k value, so that means that your graph got pushed up, moved up 10 units. So that means we're going to add 10 to the y's. So 0, 0 is now 0, 10. I know it's kind of crowded, sorry. And 1, 1 is now 1, 11. And 2, 4 is now 2, 14. I'm probably not going to have space for that one. So I'm going to use blue for the original function, f of x. So 0, 10, 1, 11, and 2, 14. So 11, 12, 13, 14, barely. So it's going to go like that. And then for the inverse function, we flip the points. Remember, 10, 0, 11, 1, and then 11, 12, 13, 14, 2. And remember, if we draw the line y equals x, the two graphs reflect. So this is my line of symmetry. If I fold on that dotted line, the pink and the blue will overlap each other. So 4 through 6, we're doing everything exactly the same except that we're not graphing now. They're not asking you to graph. So f of x is 15x squared. You've got to restrict the domain, so I'm picking the positive side. Switch the x and the y. Make the f of x equal y. And now we solve for x, so I'm going to divide by 15. So then I have y over 15 equals x squared. I'm going to take the square root of both sides, so that's plus or minus y over 15 equals x. Because I chose the positive domain, x greater than or equal to 0, I pick the positive root, so that's x equals y over 15. So switch the x and the y. And then just change it to function notation. Okay, so now we're going to confirm that our answer is right. Okay, we're going to check it out. So we're going to do f of f inverse of x. So I start off with 15x squared, so I'm going to put 15 blank squared, and in the blank I'm going to put square root of x over 15. When I square the radical, the square root, I eliminate the radical, so then that leaves me 15 times x over 15. So the 15s are gone, leaves me with x. F inverse of f of x. So I start off with square root of blank over 15. So in place of the blank, I'm going to put an f of x. So the 15 is gone. So this is square root of x squared, which is x. So again, we've got x for both compositions, so that means that our inverse is right. And our functions are inverses of each other. Alright, I'm going to restrict the domain, and again I'm keeping the positive x's, 0 and greater than, 0 and larger, so positive, or the non-negative x's. Replace the f of x with y. I'm going to add 3/4 because I'm solving for x. So y plus 3/4 equals x squared. Take the square root of both sides. And again, because I chose the positive domain, I'm going to end up with the positive root. So x equals, now I can add the y and the 3/4, get a common denominator, so I'm going to multiply by 4 over 4. So that gives me the square root of 4y plus 3 over 4. Okay, and switch the x and the y. You could even take out the 4 down here, because the square root of 4 is 2. You cannot do it to the one in the front of the 4 in front of the y because there's a plus 3. So I can take it out like this, like that. Okay, and so f inverse of x equals the square root of 4y plus 3 over 2. Okay, so the 2 is outside of the radical. So now we're going to confirm our answer, make sure that we're on the right track. So f of f inverse of x, start off with f of x, so that's x squared minus 3